Good morning, everyone. Thank you for coming along. Can I start by asking who here is new to Xamarin developed with an iOS? So hasn't done anything. Great. First part of this talk is 100% for you guys. And from everyone else, who's already built something with Xamarin.iOS, like run up some of the samples? OK, so the second part of the presentation is going to be really interesting for you too. And of those guys, how many have actually already looked into iOS 9? OK, great. Well, there might be some useful content for us all then. Today, I'm going to do a three-part presentation. So the first course is going to be a file new app. So we can walk through, particularly for the people that haven't been into Xamarin.iOS before, exactly how to set up a project and what to find when you create a project from a template. A quick discussion on how it works in the middle. And dessert is going to be some goodies from iOS 9. So I don't know if any of you attended the Android presentation yesterday done by Nish. He built a quick application that was based on a Google sample that showed landmarks for people that are traveling around. So he used Orlando as his sample. I'm going to use some photos from Sydney because that's where I'm from. And just going to throw something together quickly to give you a feeling for what it's like to file new an application using Xamarin. Great, so you can all see it. So this is Xamarin Studio, for everyone that's not familiar. We can start a new solution right at the top. Now, we're not going to do a cross-platform app. Those options are for Xamarin.Forms. So we're going to go down to iOS and choose to build a master detail app. So it's the kind of app structure that you're used to in the Mail app or any sort of kind of parent-child relationship. So when we hit Next, I'm going to choose a name for the application. I think I'm up to Demo 7. We can choose to do iPad and or iPhone for the application, and we can choose what level of iOS we want to target. I'm going to just go with the latest and use all these default settings. And once the application template has been built, you'll see there's a few interesting things in the top left corner, which is the solution pad. So the first one is references. That's where we bring in Xamarin.iOS, which is all of the iOS SDK that we can use to build our native application, and a few system namespaces. That's bringing in the .NET framework for us. Components and packages is where we can easily add components from the Xamarin Component Store, and packages is where we can pull in anything from the NuGet ecosystem that's compatible with Xamarin or is a regular .NET NuGet. The resources folder is where we can place images, localization files, which we will talk about a little later. And I'll just expand it quickly to show you. By default, we throw in a launch screen. So people who've got a Windows development background are very familiar with the concept of a splash screen, the thing that comes up while the app is loading. Apple uses that to show on the screen while the app is loading. But it also has a special purpose in terms of indicating that this application will run on various different screen sizes. So you always want to have a launch screen zip, nib file, or a storyboard file if you want to use the Xamarin.iOS editor. But that's built into the template in any case. The AppDelegate is where the real magic happens. So this is the first thing that is loaded when an iOS application runs. We provide it for you. We've hooked it all up for you. The finish launching method is the first method that you can start to throw in bits of code to start up your UI, to make changes to the UI before the user sees it on the screen. So in the template, we've got some boilerplate code here, which looks a bit messy. There's a split view controller and a navigation item. So what I'm going to do is just quickly run this application up before we go any further so you can get a feeling for what we're actually going to be talking about. And the 5S simulator pops up there. Let me just zoom out a bit. So it's a really simple application, the template. It's an empty box, empty scroll at the moment. We can add items to it. And clicking on one zooms in to the detail, and clicking back goes back to the list. So it's pretty simple. There is, let's just quick out of it, some really raw data that's being used behind the scenes. But how do we get from this code, the AppDelegate file, to loading those two screens? So there's two parts to that. First one is the Info.plist file. And this is what you would think of as your configuration file for your application. So you will come in here to set your bundle identifier. And this is the unique name for your application in the world. So when you submit to the App Store, you're going to submit that bundle identifier and say, this is my application. So that's an important thing to choose. Apple recommends the reverse domain name syntax to help you generate unique names. You can set version info and various other things. But most importantly, we can choose or change here what platform we're supporting, the orientations that we're supporting if people are moving their devices around, and most important of all, the main interface file. So when the application loads up, in that finished launching method, we didn't actually create any screens. And that's because in the Info.plist file, we just choose from the list of available screen definitions which one we want to start with. So the launch screen is in there. That happens automatically. So we want main to be the main interface file for our iPad. And while we're in here, I'm just going to click upside down so that when we're moving the iPad around 360 degrees, the application is going to rotate. There's a few other options in there. Old school launchpad images. There's where the launch screen is set automatically. But now that we've set the main interface file, we can close the storyboard, close that, and check out the storyboard file itself. So a storyboard file is going to get loaded when the application starts, and the screens and the controls and everything that we draw in this file are what define how the application looks and works. So Xamarin has this storyboard editor built in to Xamarin Studio and to Visual Studio. It's functionally equivalent to what you can use if you're using Xcode. So it's the same experience that Objective-C and Swift developers get when they're building iOS applications. So if I just zoom out a bit, there's a lot of screens there. And what most of them are doing is providing a navigation metaphor. So right over on the left is a split view controller. And it's providing the wrapper that says we can have a master detail on the left, a master view on the left, and a detail view on the right. And then we've got two navigation controllers. And a navigation controller is another container that lets you put in any sort of screen you want and navigate forward and backward between them. So we've got a split view, which can have two things side by side, and each of those things can have multiple views inside of it. So if we look more closely at the top one, and they're joined together by what Apple calls segues. So to create a segue, you can hold the control key down and you can draw them. But the template has come with these segues all built in. So let's zoom in a little on the first view. So that is our list view, the first thing that we saw when the application loaded up. It's already got a cell in there. The way the designer works is the list view that you create will automatically have one cell in it, and you can fiddle around with its design, and then it'll be repeated when that application is loaded and data's inserted. You can add more cells in there and have your application code switch between them. If you want to select the cell, like you can kind of click around and figure out how to do that, but a better way is to use the document outline. So over here, I can see the table view cell right in the navigation tree. So when you're clicking around, when your layout is complex and there are overlapping controls and things everywhere, the document outline provides a much easier and faster way to drill right in and select what you want to select. Now, once we've got the table view cell selected, I want to make some changes to it. So on the right-hand side, we have the properties pad. And these are all the same properties, as I said, that Objective-C developers are accessing when they're inside of Xcode. So there's a few things we can set. We can set a name. We don't need to do that right now. But I do want to change the style because at the moment it's just a little block of text. And I want to put an image in there and maybe some subtext. So there's a few built-in styles, and I'm just going to use one of those for today. But you can see that on the designer side, there's now a style, a title, and a subtitle. And like I said, I want to put an image, and I can choose a default image oh, I haven't added it yet. I can choose a default image, and in code, I can update the image in that cell. So if I choose a default one, it'll show in the designer as well. So without too much effort, we've made a little bit of a change to that master view. Let's go down and have a look at the detail. So there's one single label in there. It's not really impressive as a user interface, so I want to add more controls. Where are the controls? So we've got another pad that we need to show, the toolbox. So, ooh, that's an interesting spot. So let's throw the toolbox over onto the side here. And now I can zoom in. And let's search for a label. And I can drag a label in. So I might want to put it down there. And let me just search for an image view and drag that image view in as well. So I want the image to be a bit bigger. So there's two controls. Just going to close the toolbox again. So I need to give those controls a name so that I can refer to them in code. And this is exactly the same sort of experience that you'd be used to using way back to Windows Forms or Visual Basic, right through to WPF. Select the control and give it a name. So hero image, let's say. And I need to give the label a name as well. Detail, label, something like that. So now I've got some controls with names that I'll be able to refer to in code. I've tweaked the list view a little bit. And just before we close this up, I'm going to answer the question that's all bubbling in the back of your mind right now. Why are all these windows square that I'm designing for? And so that's another part of iOS 9's capabilities, is the concept of size classes. So if you want, you can design in the concept of an iPhone 4 screen. Or if you want, you can have the designer show the iPad screen, and that obviously looks a bit messy. Interestingly, when we're looking at the iPad screen, navigation view controller is only still shown like 320 pixels wide, because that's as wide as it ever gets, even on an iPad. But using the generic designer lets us design something that's going to be easily scalable. It's going to be able to get bigger and smaller, and you can view it in its other incarnations. But it leads into the concept of size classes. So when you're designing for an application, Apple has these ideas that your application view is either going to be, let's zoom in on this, compact, like very narrow, probably on a phone in portrait, very thin, probably on a phone in landscape, or huge, probably on the iPad Pro. And you can change properties when you're viewing the storyboard in each of those different size classes to make your application adaptive to the user interface that the application is being run in. So we actually do need to add some code to make this work. Oh, shoot. Someone saw me hit don't save. That's OK. I've got one prepared to sub in. But we need to add some code. So if we were to add the code here, I've got a helper file, which is actually, and just to demonstrate how great code sharing is in Xamarin, that helper file I just stole from Nish's presentation yesterday, which he had it running on Android, and a data source. So a data source is how you wire up a list view control in iOS. So most idioms when you're programming in iOS are going to be very familiar to Windows users, particularly since we expose everything as C#. But the concept of a data source delegate is a little bit different. You can't just set a collection to a list view's data source property. There's a class that sits in the middle, and if you start building iOS applications, you're going to be building a lot of these data sources for table views or data sources for collection views. And they provide an abstraction layer between your list of stuff that you want to display and the control, the list view control or the collection view control that you're displaying it in. And the purpose of it is to report back to the visual control how big it needs to be. So rows in section is, in this case, very simple, but you could have a lot of logic in there if you've got different sections with different number of rows in each. And the other important function is to actually provide the cell layout. So this is where you customize the cell further with the data that you need to appear in each row. So by default, I'm grabbing the cell instance, I'm grabbing the data for that row from my collection, and I'm setting a label property. And you'll recall that I added an image and another label. So this cell, now that I've implemented the table source, is going to take a list in as a constructor, in the constructor, I apologize, and it's going to feed out a number of rows, one for each item in the list. Now, I would try and run that, and apart from the fact that I've not saved the changes to the storyboard, you'll see there's a bit of red in there. So, you know, another example of Miguel's demonstration of how Roslyn helps us identify errors in our code. I'm actually using a component to provide the web image. So my images are actually coming from the web, from a URL, and I don't want to instantiate a web client and download it and cache it locally. I'd rather do that in one line of code and have someone else do all the hard work. So I can add packages and SD web image. And this component is brought to you by Xamarin. And so, OK, one click later, if I expand that, we have component added to the store, to the app. It's already also added to the references. The code now is going to compile. So with a couple of clicks and this one line of code, I've now got the ability to download and cache images from URLs and not have to worry about any HTTP or anything else under the covers. It even supports having a placeholder image. So, like I said, I've got a backup here that we can run to see how it looks. So this time, I'm opening it up in iPhone 6 Simulator. So there is the custom cell that we picked. Instead of one label, there's two labels and an image. And when I click on it, it zooms in, and the image and the other data is populated. So very simple and easy way to get an application up and running. Well, just before we move on, let's check it out in the iPad. So notice this time, both views come up at the start. And I can expose and hide the master view. When I rotate, it sits there permanently. So I've got an adaptive layout that on a phone lets you move back and forth between the two screens, and on an iPad blows up and tries to use all the available space in a way that's familiar to iOS users. So that's cool. What's cooler is that it also supports multitasking. So now that I can put something else up on the screen, my app sits in here, and it's in some weird width state that an iOS developer has never coded for before, like 700-something pixels wide. But the application adjusts. It stretches the images. You know, that's my bad. I was a lazy programmer. But you have a list view. You notice now that they're distinct views again. It's behaving more like the phone. So iOS 9 provides all of this underlying functionality, the split view, multitasking, size classes, and rotation handling. All you have to do is add a little bit of code. So hopefully that gave you guys that haven't seen iOS before a little bit of an idea about how the application is structured and fits together. Let's switch back to the slides, because now, as I said, one of the reasons I wanted to show you that stuff is iPad multitasking is one of the cool features of iOS 9, and using size classes, using that built-in template or some variation of it is a good way of accessing that stuff. So how does it all work? You guys have seen this slide before, if you've been involved in the Xamarin ecosystem at all. I wanted to throw it up as an intro to the next section, but also to point out a new sample that we added recently to our GitHub repo. It's called the Acquaint app. It's a fairly simple contact management app, the kind of which you've seen before. The cool thing about it is, for people that are interested in learning Xamarin.iOS, we built it in Forms and in the native platforms. So if you want to see how we compare and contrast the two platforms, how something can be done in Forms and how it can work the same way in iOS or Android, this app is a good way to look at the code written 4 times and understand the differences. But imagine zooming animation now into this side of the diagram. I want to talk a little bit more about what's under the bonnet of Xamarin.iOS. So we all know at the top, it's a native user interface that users see when they're using your application. That's made possible because we're using that storyboard file, that same storyboard format that Objective-C developers are using. You're using C# code to control those controls, to move stuff around, to bind data to the user interface. And your C# code is also optionally using UIKit, MapKit, any of the native application frameworks provided by iOS. And in between that, the C# that you write, Apple's frameworks, is this very thin little layer that we call Xamarin. Now, we used to just leave that box as a little box. Now, of course, as the announcement yesterday, this is open source. If you actually want to know what's in that box, go to GitHub. Underpinning that is the guts of your application. The shared C# code, the business logic, data access, web and file operations that you write in C# and you can share with Windows and Android and iOS. So this is code you've written before. This is not something that you're going to be doing for new when you're using Xamarin. But even so, there's stuff that you can't do in .NET that you might want to do in your application and is available on the native platform. So we have the concept of custom bindings that can bring in CocoaPods, which is like the NuGet for the iOS world, or just straight Objective-C code. You can, using our tools, create a custom binding that brings that logic into your iOS application as well. And like I said, our stuff is open source, so you can look at how we do it, as well as our documentation to help you do it. And at the very bottom, the bits that you don't really see very often, is Mono, sitting under the entire stack, providing file operations to your code, providing network operations to your code, and providing access to the underlying operating system when you need it. So you've got threading and everything available to you through async await. To the side of that is the native APIs that you also don't usually see very often, but you access at a higher abstraction level. And a good example of that is NSURL session. And I highlighted that for a reason, because it's another new feature of Xamarin. Previously, when you're using Xamarin and you're writing, pretty much all of your code is on the left. And if you've brought code over from Windows Phone or from any Windows platform, you're using system.net.webclient or system.net.httpClient to access the web, to grab JSON, to do web services, to download images. And when you're doing that, you're using the Mono network stack, the same stack that Miguel put into Mono when he started creating it in 2001 to 2003. More advanced, obviously, but the Mono networking stack. On the right-hand side, iOS provides a networking stack. NSURL session, CF network, which is Core Foundation. So there's a couple of options over there that are available to you as well. And you've always been able to new those up in Xamarin, but you would have to do new NSURL session and then use that API. So your old code that used Web Client, you had to rewrite it to take advantage of Apple's stack. Starting with the release candidate that's available at the moment, we let you, under the covers, switch your Web Client API to using Apple's native APIs. So you continue to have your systemnet web client or systemnet HTTP client code, setting your headers and doing all the other stuff that you had to access web services. But under the covers, you can choose the HTTP client implementation and you can choose the TLS implementation to use Apple stuff. So why is that important? Security. Mono's SSL and TLS implementation is great. It's open source, and it's subject to the contributors in the community to keep it up to date and keep it modern. At the moment, it's a little bit behind where Apple stuff is. So if security is important to you, and you want to, for instance, be using TLS 1.2, which is the latest version, we don't have an option for you in the Mono world. But we now have a way for you to flick a switch, start using Apple stuff, and not have to change your code. So, but to be clear, by default, you can leave everything as it is, and it will still work. But if security is on your mind, we give you this option to use Apple's APIs under the covers. And that doesn't preclude the fact that you can still access Apple's APIs directly by newing up CF Network or NSURL session. Why that becomes even more important is because another thing Apple added in iOS 9, which is application transport security. So you might have had code in the past using web services, using the .NET and Mono networking stack that's accessing insecure resources. What Apple's doing with iOS 9 is trying to encourage developers to not use insecure resources. So Apple's recommendation, only use HTTPS for all of your networking communications. So downloading an image, do it with HTTPS. Downloading some JSON, accessing web service, do it with HTTPS. If you do that, there are no changes required to your application. However, from iOS 9 going forward, if you're using HTTP connections to grab images or to get JSON files, Apple's concerned that you've put someone's password in the payload, or that you've got their medical information coming back and non-secured. So to communicate to Apple that, yeah, it's cool, this data isn't secure enough for me to care about, you can create exceptions in your Info.plist, or you can opt out of that security checking entirely. So Apple's creating this gateway that another thing you have to jump over to get your app running on iOS 9, but it's intended to protect your users. And by changing over those settings that I mentioned in the previous slide, you're going to be subject to these ATS restrictions, so you need to know about how to opt out of secure communications if you need to access non-HTTPS resources. And I'll finish talking about how it works quickly just by mentioning, again, you've seen this slide before, not only is it a native user interface that your clients are seeing when they're using your applications, it's native performance. So the entire stack that you see on the left, your C# code, your storyboards that are iOS specific, the .NET framework, all compiled ahead of time using the LLVM, which is Apple's new way forward for building applications for iOS, into a single app binary, ARM machine code, runs on the phone, and is indistinguishable from the applications that Objective-C developers are using. So it's a native runtime, high performance. So that leads us to the good stuff. How to make your applications shine with iOS 9. So what I want to do is quickly maybe demonstrate some of them because they don't fit real well on the simulator. Let me just dump that up. So what I've got here is my phone running in the background. So let's look at the Xamarin Evolve app. And the first thing I can do is press really hard on the screen, and I see effectively right-click for the iPhone. It's called 3D Touch Quick Actions. If I go into, actually, let's go down and say I want to search for XAML. Oops. Becoming a XAML master, the presentation that you're currently missing but will be able to stream online later, is right in your iPhone search index, and you can jump straight into the application from the search index. And if I check my email and someone has sent me a link to Charles's presentation, I would be able to click that link in my email, and it would also open it up in the Xamarin app rather than in Safari. So let's have a quick look at some of those features and how to code them. The first one I wanted to start with, because I just like talking about it, is UIStackView. And if your background is in pretty much any other user interface metaphor than iOS, this is not news to you. WPF and Silverlight have had this forever. Android has had the concept forever. It's just a way to lay out controls in a grid. Like horizontal and vertical grids that can expand and contract to make adaptive user interfaces easier to build. Objective-C developers have struggled with doing this manually forever, so this is a welcome addition to iOS 9. But what's really cool about it is that it's also localization aware. So when you build these grids, you don't align stuff to the left or align stuff to the right. You say it's in the leading or the trailing side. So the Dunn label and button are leading and trailing. The save and cancel button are leading and trailing, which is great if you're building for right-to-left language support, because now the button, you can't tell that the red and blue ones are different, obviously, unless there might be some Arabic readers in here. But the switch is on the left and the label's on the right, so it knew to switch those over. Even better for localization support, the whole iOS operating system handles right-to-left better. So you'll notice that the to-do navigation button is on the right side as well. Swiping back and forth, everything's flipped. So localization into right-to-left languages like Arabic and Hebrew is now a hell of a lot easier because the operating system supports it from the navigation metaphors right up to the layout controls. How do you do localization? And not just right-to-left, any localization? It's surprisingly easy, and it's something that I think has a history of being hard to approach or hard to add to an application. iOS has a built-in mechanism that's simple to understand and fairly easy to add. So in your Info.plist, again, I mentioned that was like the configuration file for your app. You add a localization section and select which language you want to support using the regular code, so German, Spanish, Japanese. Then you slightly restructure your application. So when we looked at the first demo, the storyboard was just in the root. And when we added, if you add classes to that, they all get added next to it in the root. For localization, Apple has this concept of an lproj directory. It's a language project. And base lproj is where your default files go. So your storyboard, or your code, and probably the strings that you write in there are going to be the ones that you speak natively in English. And then, in the resources directory, which I mentioned earlier, you can also throw images, you create subdirectories, which is an lproj for each supported language. And within there, you can create files that let you localize Info.plist strings, localize any string that you want. So give me a string and I'll give you back the translation. And the bottom one looks a bit confusing. It's how to localize storyboards. So every control that we've dragged and dropped onto a storyboard has a localization ID, which is the weird kind of code. So there's 3 different kind of ways, not that confusing. This is how you use them. The Info.plist strings, that changes what goes with the icon. The localizable strings, you grab them in code using the localized string method. And we'll pull that out, and you can use that to get a substitution, to set something on the user interface. And for the storyboards, text to change automatically, you match up the localization ID on the interface designer, and you add the property to the string. So that's it. You can get your applications running in multiple languages. And if you're doing right to left, you know that the operating system, as long as you're using stack layout, is going to help you to lay it out appropriately. The next thing I want to quickly talk about is Core Spotlight. The functionality I just showed where my application's data is searchable from the global app phone search. So there's two ways that you can look at doing this. The first one is for like a to-do application on the left. Every time the user generates some data, index it. And think of the index as like a 3-column database: ID, title, description. And that's what's going to be the searchable text. When they type something in, you want to add it to the index. If they ever delete or update that content, you want to update the index. And then it's always searchable. Siri can find those things if they ask for them. The second way you might want to use it is the way the Xamarin Evolve app works, where you've got reference data. So it's every session that's on Evolve this week. When the application loads, it checks to see if the search data is there, and if not, just index the whole lot quickly in the background. So tight loop, and every time that updates, update those elements. The code is really simple. The index method at the top there, you would use no matter how you're doing the code. So you would add that index method in your to-do app, or you would create a tight loop, like I've shown at the bottom, in your application startup code in the Evolve sample to push all of that data into the Core Spotlight search index. And like I said, think of it purely as a simple 3-column database. Set the title, description, and you'll get a string GUID-like ID that you can use to reference them later, particularly if you want to delete entries. Oh, and then what happens when the user does a search? Like, it's literally that easy to put the content into the search. When the user does a search in the operating system and you want to take them back to the application and back to that location in the application, you implement continue user activity in the AppDelegate, which was the first code file we saw, really the root of your application. And continue user activity is used as a landing method for a number of different functions that we're going to talk about. So we check for the activity type. The application's just been started or woken up because the user is continuing some activity that was initiated outside of your running application. The activity type tells us it was a search. We can grab the search information via this user info object for key. Those constants remain the same. And continue navigation method I haven't shown, but that's where you new up the view controller for that bit of data and populate it. And maybe you optionally hide the data that's currently showing, maybe you don't. It's an implementation detail that you can decide upon when you figure out what you want the application to do as a result of a search query. The next one is kind of related, NSUserActivity and Handoff. So everyone's seen this little icon like appear in the bottom left of their iPhone and wondered why it's there. What prompted that? There's a number of different things, including like beacons, geolocation, reminders, other people nearby you. So this Foursquare one was actually just because I was in the hotel. But Handoff is a specific mechanism that works between iOS devices and Macs to pop up the relevant information to the user. So this was pop up relevant information about my location, but you can pop up relevant information about something the user is doing. So in this case, it lets me start working on my iPhone, and if my iPad's nearby, while I'm typing in that to-do item, I could continue it on the iPad. And you do that by, while the user's working, continually updating an NSUserActivity object with the in-progress data entry. And the operating systems themselves are pinging each other and communicating with the status of that. There's an activity going on that might be usable over in the other device. And if I swiped up from that notification icon, the application will start and you'll be able to continue off from that place. So enabling that this slider, is really simple. I need to create activity types, things that the user might be doing in the Info.plist, and add code to run them. So in the view controller, I set up my user activity. It's not eligible for search. It's not eligible for public indexing, and you can look out the details for that online, but it is eligible for handoff, which means I can use this screen on multiple devices. And I create this content set with the name of it, and at the very bottom, I say become current. So while this view controller is open, so it's the to-do entry, users typing in, the NSUserActivity is being updated. And on the target device, which is your same application, it's installed on both. Again, continue user activity is the first method that's called. And again, we check what activity woke up my application. What am I supposed to be doing? We grab out the relevant user info, and again, continue navigation, application-specific code that you can check out in the samples that does something. Opens the view controller, populates the half-entered data that I packaged up in the NSUserActivity on the first device, and the user, to them, it feels like you've ported their work state from one device to another. And if you're working on Xamarin.Mac, you can actually make it work to their Mac as well. Universal links is another cool one. So this session that you're in now, the URL for that on the Xamarin website is evolved.xamarin.com/session. If I sent you an email or a text message with that link, and I also send it to people that aren't in this talk that have Android phones, you can all click on that link, and it will generally open a web view, like Safari or Internet Explorer or whatever. If you're on a phone that you already have the application installed, it will take you into the application and into the relevant session screen. So this is great for search. Like search results in Google will take people into your app without losing them in the web. You can deep link right into specific pages. And it's super easy to do. But it provides a way for you to tie back your website to your app. So 3 file edits are required. On your website, so this is like very rare, we're actually talking about doing something in Apache or IIS or wherever your website is hosted. You create that JSON data, and you identify your app ID. So pretty much the very first thing I said in the talk was you set your bundle identifier for your app. This is that same identifier. So that's how the operating system knows which app to open. And then you set the paths that work. Your website might be huge. Your app might only be able to replicate a handful of pages, in this case, the sessions. Inside your app, there's an entitlements file where you say which websites are going to be sending me like links, which websites am I associated with. And you do this so that people can't spoof or pretend or grab your links into other random apps. And finally, when you're on Apple's website, setting up your application for deployment, you tick the associated domains box, which basically tells Apple, look for that file and look for that file. And if you do all that, your links will always open your app. The only thing you need to add is the last mile, getting them to the view controller that you want them to see. And again, we use continue user activity, which is the first method that happens when your app is woken up from something happening outside. We grab the web page URL, figure out what they want, and continue navigation. We navigate them to where they want to go. Again, it's application-specific code, what you want to do there, but the infrastructure to get them into your app from search is really simple. And finally, I want to talk quickly about quick 3D action. Again, it's simple to set up. The Evolve app is doing this already, and you can check it out. Set up the tweet, a shortcut, code, and the menu shows on the screen when people push really hard. This time, we're not using continue action because the effect is happening actually in your application. So we have launch shortcut item, perform action for shortcut item, and handle. The first two are called alternately. If your application is dead and not already in memory, the first method gets called. If your application is already running, so potentially the user is halfway through some other thing, and they're going to be interrupted by this, it's a different method. So you can handle that. You can ask them, do you really want to do this? Do you want to save this work? And then finally, I've just used a handle shortcut method item. That's where you would actually then do the navigation that you wanted to do, so show the tweet window or show the mini hacks window. Man, I'm having trouble with this clicker. So I actually mentioned this already in this talk, but Xamarin.Forms is one of our examples of how to use iOS 9 functionality. But it's a Xamarin.Forms application. So just because you're using Xamarin.Forms, doesn't mean you can't access iOS 9 specific fancy bits to make your applications really impressive, even if you can't do Spotlight, user activity, and universal linking on Android. In fact, you can, but you then have to go and write it custom for that side. But you can bring that stuff into Xamarin.Forms. You can build it easily into your native iOS applications. But one more thing, I just wanted to finish with Visual Studio because we saw in the keynote yesterday, not only do we provide everything that we looked at, editing for iOS applications in Visual Studio, editing the storyboards, building and testing with the new iOS simulator that we announced yesterday. You can also tether your iPhone to your Windows box and do your testing right there, including stop debugging, stuff that Miguel showed. And that's it. This is the sample code, so we're running out of time, that you guys can grab. I will tweet the slides in like minutes, so you can grab all this stuff. But it's all available online, including Nish's sample app. I would recommend these two talks at 2:30 if you're interested, async await, or learning more about the designer and really drilling into, I quickly showed you the storyboard editor. Alex built it. So check that one out if you're interested in iOS layout. And yeah, that brings us to the end.